Welcome everyone to this exciting session about open source AI infrastructure. I'm impersonating you, Yann, at the moment. You can impersonate me if you want. It's my big honor to be here to moderate today's panel. It's such a distinguished group of speakers. I will just very briefly introduce you. I think many of you are already known to everyone in this room. But to my left, I have Bill Gia, your VP Engineering at Google. And to his left, basically, we have Neil Lawrence. You are the DeepMind professor in machine learning at the University of Cambridge. And last but not least, we don't have me. We actually have Yann LeCun. You are the VP and Chief AI scientist at Meta and also Meta Fair. And you are all here today to be part of this conversation around open source AI infrastructure. So as we kind of set out to discuss this topic, I wanted to first actually give the word to you, Bill, to kind of take us through a little bit, what do we actually mean by that? What are the different layers that we need to consider when we're talking about that?
Of course. Thank you, Hannah. I'm very happy to be here. In terms of AI infrastructure, I think a lot of people, you understand AI by knowing like Gemini and Llama from Meta, or ChatGPT from OpenAI. So those are AI models, which a lot of people get to know AI, get to use AI, right? But how that model coming from? As a matter of fact, it's all supported by AI infrastructure. Say, for example, we have something called AI framework, like PyTorch or JAX. So all these AI models built upon the AI framework. That's part of AI infrastructure. And after model has been built, the model needs to be trained. Then all the large-scale training infrastructure is also AI infrastructure, part of AI infrastructure. And of course, after the foundation model has been trained, all the fine-tuning, all the evaluation, and after everything's done, we have to inference model in production. The AI inference is also part of AI infrastructure, right? And of course, at the lowest level is all the AI hardwares, like NVIDIA GPU, and AMD also has their hardware. Meta's doing the hardware as well. Google has the TPU, and the AI compiler, which is actually compile AI model towards the AI hardwares, so that the model can run really reliably and performantly. That's also part of AI compiler, also part of AI infrastructure.
Okay, so there are these different layers that we need to consider. And I mean, all three of you are basically really strong advocates for open science in general. And maybe just to start off with, like, why is this topic so important, and maybe also how can open source AI infrastructure help improve transparency, like in research, and also the reproducibility. Maybe Neil, as the academic in the room, if you want to say something about that.
I guess as the academic in the room, I would have given a slightly different answer to Bill. Because I sort of don't know the answer to the question, what does open source AI look like? Because people seem to give a lot of different answers. So I have this trick then that I answer a different question. You might see me deploy it a few times. I think that the right question is, what does open innovation look like? So you've mentioned open science. That's part of it. And I think a lot of the questions, and Yann's been a great champion of what open science looks like. But I think the challenge we face at the moment is we don't have open innovation. So when we look at the difference between the type of solutions we want from these technologies, so improvements in health, education, more equitable lifestyles for people around the world, we're seeing very little delivered in that regard. And what we're seeing is things that make the rich get richer and basically don't answer the questions people are asking of us. And that indicates there's something wrong in the innovation life cycle. And I think open source AI, the infrastructure that Bill's talked about, is part of it. Many of the things that Yann talks about is part of it. But I think that there are additional blockers around data and capability that we can't ignore when thinking about open innovation in AI. So I often try and lift the conversation to talk about that, because there's very little I would disagree with on Yann or Bill in the areas that they often talk about. But then I think there's a lot more to say about how do we bring this capability? So open innovation in science, yes, brilliant. And we do an enormous amount of that in Cambridge, supporting scientists to use these technologies. There are challenges there. But the much bigger challenge is how are we getting these tools in the hands of teachers, nurses, doctors, regular citizens to deliver on the sort of solutions that society wants. And I think that's an enormous question today.
So Yann, maybe, I mean, I think, with your comment there, Neil, you're taking a bit of a broader look, right? So you're looking at, I think you talked to us through these levels, but of course there's also the application level, there's access, there are a lot of things we can be talking about. I think you talked about access to like getting it in the hands.
And the capability can be multifaceted because, for example, capability like builds is not the sort of capability people are always talking about, but if you're going to deploy a model in production, you need it. And it's perhaps in shorter supply than the sort of capability that Yann and I used to have before we sat on panels all the time. Yann probably still has.
Yeah. No, but I want to hear also your take on this, Yann, because I know that you're also a really strong advocate in this field, and I also know that you and Bill actually in the past have had the pleasure of working together, and that you're kind of strong advocates for this. So I would also like to see, as we're diving into today's conversation, how do you see that contribution, and why is it important to you to be an advocate in this field?
Yeah, Bill was at Meta until fairly recently.
Yeah.
And caught the open innovation virus, and now is infecting Google, which is hopefully. But I mean, we already had that effect with the creation of FAIR. It actually caused other players in the industry, Google in particular, to become more open because of us. So there's several types of openness, right? There's open research, obviously, and which means publication, open source research code, and things like that, and communicating with other people. And really, what has enabled the fast growth of AI research in the last dozen years is open research from academia and industry. And by the way, I'm also an academic. At least I have a foot. I'm also a professor at NYU.
He's a better paid one.
Say again?
Better paid. I think.
Yeah. So the sad thing is that in the last 3 years, the companies that saw AI as being a competitive advantage have started climbing up, at least at some level. So Google, for example, JAX is open, and most of the contributions come from Google, but and then some of the compiler stuff, but things above that, except for Gemma, are not very open, and it's certainly OpenAI, Anthropic, etc., are completely secret, which I think is sad because it's kind of slowing everyone down. So at Meta, we kind of remained open, and the reason is open innovation. It's the fact that the existence of Llama basically has enabled the emergence of a whole AI industry that would not exist without it. And it's, I think, very important because it allows a lot of people to fine-tune those models without necessarily having thousands of GPUs at their disposal, to fine-tune them for vertical applications in healthcare and all kinds of other areas. But I think there is another reason, perhaps even more important, for foundation models to be open. And it's the fact that slowly but surely, AI is going to become the repository of all human knowledge. And so all of our interaction with the digital world will be mediated by AI systems. I'm wearing smart glasses right now. I can ask Meta AI whatever question I want. I'm not going to do it, or maybe I don't have signal.
Only if I come up with a really tricky question.
Right.
If he suddenly stops mid-sentence, you know his PR person's on the glasses.
No, actually. Or if they try, I ignore them. So what's important is that we need AI engines, models, whatever you want to call them in the future, to understand all the world's languages, to know about all the cultures, all the centers of interest, and everything. And no single entity can do this by itself, because no single entity has access to all the data in the world. I mean, we have access to a lot of data, but it's public data. There's a lot of data that needs to be collected if you want AI systems to speak all the, 30 major languages in India and all the, 500 dialects. And, there are similar numbers in Indonesia and various other countries. And just speaking all the languages in Europe, right? Just in Switzerland, right? There's at least 2 languages that are not spoken by a huge amount of people: Swiss German and Romanche. So French is actually spoken by more, but Romanche is only a few tens of thousands of people. So we're not going to have AI systems that speak those languages unless the countries that have a vested interest, or the groups that have a vested interest in constructing the data sets for it, actually collect them. But then they don't necessarily want to just hand it over to a big tech company on the west coast of the US. And so what that leads to is a future in which foundation models will be trained in a distributed fashion, so that people who have the data keep their data. They don't have to ship them to anyone else. But they contribute to training a global model. And we need also AI systems to be diverse, because since they're going to be filtering all the information we get through our smart devices, we can't afford to have those be produced by just a handful of companies in the US or China, right? They have to be diverse for the same reason the press needs to be diverse. So that's I think the main reason why we want to promote open source. And right now, the obstacles to open source, particularly in Europe, are legal and regulatory. So there's a risk to distributing open source AI systems, and that risk might increase because of regulations, misplaced regulations.
Thanks, Yann, for that take. And I think, we all know that Meta is really pushing for these topics also, and that you are a strong advocate for this. And maybe at this point, I want to take a step back, because these open source models like Llama, like Gemma, but also the frameworks like PyTorch and JAX, or initiatives like OpenXLA, basically, these are driving rapid innovation in kind of open source AI infrastructure. But then, Bill, how does that translate into progress in AI research and development, right? Because I think that's a little bit where we were going already, but like, what's that connection? Like, how is that feeding into it?
I'm myself is a very big proponent and advocate for open source. As a matter of fact, Yann's friends and ex-colleagues at Meta, back at Meta, so I think I had a lot of discussion with Yann back in the days on PyTorch. We did PyTorch. We're thinking about, hey, how can we open source PyTorch? The reason that we really want to open source PyTorch, and now at Google we open source JAX, is because we understand, because Meta and Google are both very big company. We're financially very backed to do the AI work. We understand doing AI research work, how intensive, how much capital it needs, right? We want so AI researchers, if every single AI researchers they don't have access to the like open source AI infrastructure, then if I just imagine everybody, hey, you know what? I want to build this Llama model. I want to build this Gemma model. I want to build this ChatGPT model. Then I have to develop my own framework. Then before even I do my AI research work, my push on AI research innovation, I have already spent like 90% of my time to do the AI lower level AI framework, right? Then that's going to be very much slow down the AI research, AI innovation. So that's one reason that back at Meta, Yann and me both are very big proponent on open source. I really appreciate Meta actually really open source JAX, create JAX for open source PyTorch. Just testing if Yann's listening. Open source PyTorch, and we create PyTorch Foundation, and all the major players join PyTorch Foundation to make PyTorch even more successful. And of course, Meta also open source Llama, which all the industry appreciate, because people can, based on Llama, fine-tune it and build different models, just push on AI research, AI applications. Now back in Google, of course, we open source JAX in big way. We actually make JAX available for every AI researchers to to build AI innovation. Then we also make JAX and XLA, which is the AI compiler, accessible for all the AI hardware providers like NVIDIA, AMD, and AWS AI hardwares. So by doing this, we believe AI researchers can just leverage all the available AI infrastructure software very quickly iterate all the AI research models, AI innovations. So we don't have to slow down by the fundamental layers of the AI stack. So everybody just focus on that AI innovation. We believe the universities and the startups, they can just do very quick work. Otherwise, they cannot do anything because they need a lot of capital to this fundamental stuff.
Okay, so like Neil already pointed out, like we risk finding consensus when we talk about why open source is important. I mean, I think we've seen, that you all see a lot of value in this, but maybe to maybe unpack a little bit what can also then be the challenges. So if you want to maintain, like build and maintain these type of open source AI infrastructure ecosystems, what can be challenges, for example, when it comes to interoperability or things like this? Neil, do you want to start off with that?
I think that the major challenge is that what we've seen happen, as Yann said, these innovations came out of academia. Even JAX was started when academics moved into Google. It was an academic idea or an evolution of an academic. And then they're supercharged by industry. And what goes on when that happens is industry sort of borrows from academic-like behaviors like publishing in conferences or putting in archive or getting something in Nature. But then they do it with this enormous PR resource behind them, which academia typically doesn't have. They also do it unencumbered by the need to develop the next generation of students. They do it, broadly speaking, unencumbered by the social obligations of academia. I find it sort of remarkable. I had this image once. The way we treat industry as a society is a little bit like the way we teach a child who's potty training. Every time they do it in the right place, we sing their praises as if they're the best little chap or chapess on earth. And when they do it wrong, we're like, oh, don't worry, maybe better next time. And this has become societally cultural. We don't have the same moral obligation around industry's behavior that we have around public sector or academia. And this has led to a sort of challenge that when industry is doing something right, it's shouted from the high hills as if, isn't this wonderful? When in fact, most of the good work is going on in public sector and academia. And exactly the thing Bill highlighted, despite the good works of, say, Bill and Yann, this leads to a problem where we can't actually engage with the creation of these models. And that's important. I mean, actually, I was looking at Yann and I were on a panel in Lille in 2015, and I was rewatching the whole thing. And at some point in the panel, we were asked about social obligations, and my answer was, we're the tool makers. We need to provide society with the tools. That means the small players can engage. But there's zero incentive for big tech to sort of do that. To the extent that they do that, they're providing a tool that they built, and they built by supercharging an academic process, which academics can't do. And in the process of doing that, they're destroying the academic system. So there's an alternative future or alternative path that could have happened that would have been that we don't yet have large language models because industry wasn't interested for some reason. And this work was broadly done in academia. And it takes 5 or 10 more years to get there. But we get there because it would have happened, right? And at that point, this technology is distributed across all academic systems. It's accessible to all universities. It's not restricted to a few industrial people that saw a business opportunity in the technology. And at that point, the technology would be far more diffusive, going into the type of applications all of us care about. And the problem is that's not what's happened. And we're now sort of looking back at it and sort of saying, well, how can we squeeze that back in? But none of us can afford to hire Bill. And none of us can afford to hire the team around Bill to support the deployment of those models in practice. And I see this as a desperate problem, a really desperate problem. And it's why innovation economy is failing. And it's why people are angry. Because if you ask citizens, they say, well, we wanted technology to affect these things. And you're just arguing about TikTok. And actually any startup is trying to do the next TikTok. They're not trying to solve the hardest problems in society. Sorry, what was the question again?
Challenge.
So I think
challenges. Yeah, so
yeah.
I think this is the most enormous challenge. And it's really difficult because what's happened now is that big tech has gained massive government mindshare. If you look at the recent UK AI Opportunities Plan, it's totally dominated by what big tech thinks. We're lucky that in France, Yann actually said to Macron, you need to do open source. They've almost killed the open source ecosystem in the UK because big tech told them to. And now we're in a situation where, not Yann. In fact, Yann, the reason why France is surging forward ahead of the UK under Tortoise Media's indexes is Yann saying to the government, you need to back on open source, right? So the challenge is that it's really difficult because if I stand up or put headlines saying, look, aren't big tech evil, they're not solving these problems, that doesn't help. Because we need to solve these problems together across big tech, small businesses, universities, governments. We need a conversation that addresses the real challenges. But to be frank, big tech is not incentivized to do that. And at the moment, they have, in the UK, almost total regulatory capture in terms of what decisions are being made, even though I don't think the government's aware of that.
But listening to you, Neil, what do you think that like working in pair between the private sector, academia, government, what would it need to look like?
Well, I think one of the first major challenges we have is we need to move away from this absurdity of talking about artificial general intelligence. Because you've got major tech companies whose now valuations are based on the idea that they'll solve AGI, even though it's a meaningless idea. No one even knows what it is or agrees what it is. It's a little bit like driverless cars were about 5 or 6 years ago. The investment in autonomous driving was enormous because Elon Musk has said we were going to have them within a couple of years. So it felt existential. It's now existential to these big tech companies. So the pressures internally are not to care about real world problems. They're to what's our route to do AGI, because that's what's holding up these extraordinarily high share prices. It's a really the biggest problem, I think, is that argument's going on and each company has to have that discussion about how they're delivering things. But the media has been drawn into it as well. So the higher quality tech reporters don't tend to question this narrative and don't tend to say that this is a problem and what are you doing on the ground? And if they're asked what you're doing on the ground, it's like, oh, we opened a research center in Nairobi. Great, thank you. That conversation sort of needs to change, and we need to start talking about why are you not addressing, we've got 10 years of what citizens say they would like this technology to do, and we've got consistent failure of big tech. They've tried in health, consistent failure to actually deliver solutions in that area. And people need to start asking those questions. Why is the innovation economy failing to deliver to our citizens? Because our citizens are rightly angry about this, and what they do in response is they move to other models that they feel, rightly or wrongly, will deliver. And it's undermining our democracy.
So I mean, Yann, Neil is passing the ball to you a couple of times here, right? So he's giving his take on what role you are taking in this like innovation system to promote the open source ecosystem in general, but also, of course, at the end of that process, the positive outcomes. So do you share his view of how he's describing this ecosystem and the players, their roles within it?
So I agree with many of the things he says or he has said, but have a more nuanced view, or perhaps a little more circumspect. Partly because I started my career in industry at Bell Labs, and so this phenomenon that you're describing, that innovation chiefly comes from industry and not academia at the moment. I'm not talking about research. I'm talking about technological innovation. This is not new. I worked at Bell Labs. Bell Labs invented the transistor, the laser.
But what is new
cells,
is where that was being deployed. Everyone got a transistor radio. And I think that the new thing is that in the modern innovation economy, the way you make money is by capturing our attention, not in a productive way. It's by advertising. Whereas in the economy then, it was making products, washing machines, things that were changing people's lives, hopefully the better. I know it's not entirely true, but that would be the way I view a slight shift.
I'm coming to this, right?
Yeah.
So there is a role for industry and academia. And it's true that a lot of new ideas come from academia, and most come from academia. But then, turning them into kind of real things, if you want, generally comes from industry. But sometimes also innovation comes from industry from the start because the resources that are required for it, are large or complicated. Academia didn't have clean rooms to build integrated circuits, for example, that had to come from industry. And so, things of that type. This is not a new phenomenon. It's not specific to AI either. So that's the first thing. Second thing is, we've got to be careful when we talk about big tech. There is no such thing as big tech. There is, first of all, some of the companies you're talking about who's propping up their stock by claiming that AGI is coming soon, they're kind of small tech, really. I mean, it's, it's OpenAI and Anthropic, right? They're not that big.
They're big relative to the type of startups that might be helping a group of teachers in a county. I think it's all a matter of scale.
And they get lots of money from, Google, Amazon, etc., right? Then there is big tech, like...
and I think some are being investigated for competition breaches by effectively being in cartels with other more well-known big tech.
Well, yeah, because they get, they need the capital investment.
They're the innovation instrument of larger companies.
Absolutely. And then you have, other big techs like Amazon, Google, Microsoft, etc. And then you have Meta. And Meta is kind of a bit of a singleton in the sense that, in advocating for open platforms, that puts in a completely different population, like, of favoring innovation from academia. Like there would be no work on large language models in academia if it weren't for open source model. And the best ones come from Meta or from China.
Yeah, but conversely, there would have been no Google or Facebook if it hadn't been for open source origins coming out of academia in the first place. And this is the problem that it's sort of one. It's like the extent to which these companies are based on the open source innovation, and the extent that it has served these business models that are about attention capture, but has failed to serve the models that are a bit more nuanced. And I totally agree. It's not just about academia; it's about industry as well. But we're not just talking about academia not being able to compete. We're talking about small businesses not being able to compete. We're talking about a situation where someone with a bright idea to make a doctor's life better, who's a doctor themselves, would struggle to productionize that. And I think that's a real problem, because they just like an academic, they don't have access to the type of capability it might take to deploy. With the exception, of course, if they choose to go the llama route, and much applause for that. But in some sense, that's already a predetermined model that suits the way that big tech has built these things, rather than something that might have been a bit more evolutionary. Sorry, I interrupted without Hannah coming in to get you in, Bill.
One thing that's pretty unique to AI, actually, as Yann pointed out. So AI innovation, typically, if you look at AI innovation at the highest layer, is this AI model, right? Now, AI models or the large language model is pretty different from the model in the past, like CNN based. This large language model is so big and consumes so much compute and needs so much data, which actually naturally makes the big company in a better position to do that innovation, right? So, of course, we have done a lot of AI infrastructure open source, which actually allows startup and academics to build models. But imagine, because they can use AI infrastructure frameworks to build models. But after model has been built, then how to train the model? That's a big question for the small company and for the academic, which is very different from the traditional.
And I'm even more curious about that. Is the reason it's potentially the case, hypothetically the case, that the reason that's true is because when companies started getting gains with large language models by just increasing the model size and increasing the data. In a company, you don't stop. It costs you more, so you just keep going, but you're getting gains, and there's a business.
That's right.
So that's how you get to $100 million training. Whereas in academia, that wouldn't have happened. There would have to have been some sort of understanding what's going on. And it might be, conceivably, but there's a better way of doing this. I mean, I strongly suspect. I
100% agree.
And that we've missed that way.
Yeah.
And we're unlikely to find that way as quickly as if we, well, maybe
I don't think we do, because that's one of the big reasons for open sourcing Llama, which is that we get a lot of ideas coming out of
absolutely.
the woodworks on how do you make it more efficient, how you quantize the weights on one bit, so you
Yeah,
can do like logical operations instead of arithmetic ones.
Yeah.
How you can implement this in hardware efficiently. The fact that it's open source causes companies like Grok, who have efficient inference hardware, to pick it up like within weeks and basically distribute it
But
to
the thing we don't get, and this is the thing I'm nervous about, and we're trying to work on a lot, is the stories, and we've got some of these. We've got a great story of a local government planning official who has been working and has managed to reduce the planning cycle from 14 months down to sort of a couple of weeks, potentially, looks like, so that you could get well-reviewed planning applications through, which is a major problem in the UK at the moment, much, much quicker, with a bit of fine-tuning of an LLM. I don't know, but likely one of the Llama models. And these are the sort of stories. So those stories we hear, I think this is another thing, it's a problem also in the VC ecosystem. It's not like VCs are doing a good job of building companies that are solving what a local planning official is trying to do. They're also steered towards large-scale problems where the VC can see a 10x return. If we go back to your days in Bell Labs, VCs didn't really exist like that, did they? There was a totally different way. So Clive Sinclair, who created the Spectrum, I mean, it's extraordinary what he did. He sold products before he built them. He marketed his products before he'd built them, and then once he'd got the people who mail ordered these products, he was then on like a 6-week timeline to try and deliver these products. I mean, it's mind-blowing. But of course, that meant he had to be utterly engaged with his customers. And one of the challenges I think we face with VC today, you can go a very long way down the product development before even smelling a customer. And if you're going to be in that regime, you have to be you're going to be the next TikTok or Meta or whatever else. So I think that's also different to the Bell Lab days, right?
I mean, a lot of things are different from the Bell Lab days. But one thing I did though when I created FAIR 11 years ago was to pick the most interesting things that I saw at Bell Labs on how you run a research lab in industry, how you try to give a long leash to scientists and not tell them to, because you can have innovation on schedule, but you can't have breakthrough on schedule. You have to let people kind of do a little bit what they want and give them a long leash.
But ironically, we're all sort of somewhat competing with that, just as people were with Bell Labs. But it's almost at a larger scale now, with because people have copied the model. There's DeepMind, Brain.
Well, I mean, there's stories in the past in computer science, in AI, as a matter of fact, when, for example, in the late 90s, early 2000s, working on speech recognition as an academic was almost impossible. You were in competition with IBM, Microsoft, Google,
Larry Jekyll,
and BBN and a couple of other companies, and basically as an academic you could provide some idea and demonstrate that they worked on kind of small case samples, but there was no way you were going to have a competitive speech recognition engine. That just required too much engineering. And so that story already happened. I mean, it's happened before with speech recognition 10, 15 years ago, or even more, where academia basically dropped out of it. It also happened with things like OCR, character recognition. You remember back in the old days, you could buy a scanner and it would come with a free OCR engine. This was done by basically a handful of companies in the world that weren't making much money. They were mostly in Eastern Europe or China. And the academic field of OCR, which was very vibrant before, basically just disappeared.
But also with chip design, I think, as you've already mentioned, but what was interesting is CISC chips, then RISC chips, which did come from academia,
That's right.
but needed to be transferred back into, and was another revolution.
Well, the design can be done in academia, particularly if it's open, like RISC-V, for example. But actually manufacturing competitive chips, that is not my industry.
Yeah.
Yeah, I mean, it's such a lively conversation, and I love how you're interacting with each other, and we're going in all directions and exploring how this might have an effect. And I mean, we're not taking questions at this time, but I would love to actually pick up something you were saying a while back, Neil, because you were talking a lot about how this can be used for good and so on, and actually, Yann, I know that this is also something that's close to your heart, and like how can we actually leverage open source for positive development in the world.
Yeah.
So I know that this is a very hot topic for you, and maybe you can share a little bit what the connection actually looks like why is that relevant, and how can it enable this?
Well, let me take an example. People in India would like to have AI assistants, and there's two obstacles to this. The first one is inference cost is too high. So we have to reduce the inference cost by a factor of 100. So there's a lot of people saying, oh, the AI industry doesn't care about reducing the power consumption and inference costs. That's not true. There's enormous amount of resources poured into reducing this, because that's the main cost item when you're running an AI system. All the tens of billions that all of the big tech companies are spending on infrastructure, it is because inference, particularly for AI systems, but inference is expensive. So reducing the cost is already a big item where hundreds of engineers working on this, thousands, I should say. But the second problem is the one I was referring to earlier, of systems that understand all the languages and cultures. So when some people in India have done, people with money, is fund academic projects to fine-tune Llama so that it speaks all the 29 or 24, I don't know. I get a different number every time. Official languages in India. And now that has become sort of a partnership with Meta, because Meta has an interest in this model, speaking all languages in the world. It turns out India is actually the biggest market for Meta in terms of number of people, not revenue, but number of people. And Meta has done this interesting experiment where they've given glasses of this type to farmers in rural India to see what they would do with it. They love it. They can look at a plant and say, this looks sick, what disease is this, right, in their own language. And the image recognition system tells them, well, you have a bug. Here is the way you treat them, or it's time to harvest, or whatever. And so I think this type of technology is going to bring, if we can bring the inference cost down, is going to bring AI assistant to a very wide population and give access to technology to people who currently don't have it.
I think, Bill, there probably would be a good place for you to contribute, because I know that by thinking about these different layers and how you can make them more open and also interchangeable, that opens up maybe possible routes there, potentially. Or would you mind sharing a bit how that can help?
I think so doing AI work primarily has two parts. Everybody understand. First part is the AI training, right? Building the AI model, then train the model. The second part is after the model has been trained, put model into production for inference, right? So we need to optimize on both fronts. So if we talk about optimize both fronts, I have to come back to talk about PyTorch and JAX a little bit. So PyTorch, so when we, Yann knows about it, when my team at the Meta back in the days when we start to do PyTorch, so AI's research innovation is really booming. Was really booming. There's all kind of AI architectures, like CN, RN, just name two, but I can easily name 10 other different architectures. So PyTorch, then we think about, okay, how can we allow the academia and the research people build AI models in very different formats very quickly. As a matter of fact, after the model has been built, when we train the models, model training takes a long time. If the model architecture is very innovative, then when training happens, then if everything is not working very well, say for the model is not converging, or performance not very good, or reliability is not very good, you want to look into the model training process and debug it. So that's where PyTorch comes into play. The PyTorch, the developer experience is really good, because PyTorch actually leverage the Python's eager mode. Eager mode means when training happens, the execution of training process is the code execute line by line. If it's line by line, if anything goes wrong, you can debug it and trace it pretty easily, right? That's PyTorch. Now, after suppose the model has been done, you have to go to production for inference. But inference cost is for the AI work, the inference cost is very dominating because inference is where the billions users query coming in. There's a lot of queries coming in. So if inference cost increase by 5%, but then multiplies like billions queries coming from users, that's a big deal, right? Then that's actually the major mentality after JAX at Google. Google's like, hey, JAX, if we build these AI models, the cost training for inference is very high. How can we make the model really works very performantly, very efficiently during the training and the inference? So JAX is a compiler-based AI framework. Compiler-based means, okay, I'm look at these AI models, then I'm going to analyze model in every single details. I'm going to optimize the model in very big ways. Like Yann mentioned, I'm going to quantize model, I'm going to fuse model, I'm going to retransform the model so the model is very efficient. That's the first layer of optimization. The second layer of optimization is look at, okay, eventually the model is going to be run on NVIDIA GPU, or on CPU, or on Google TPU. Google also have our own AI hardwares, or on whatever other hardwares. Then based on hardware characteristics, then do the really fine-tuned last mile optimization. So the model actually really runs either during training or inference in a very efficient way, right? So now you can see PyTorch is very good in research, innovation, flexibility, and JAX is very good in efficiency, reliability, performance. So these two things actually complement each other. Now, the question comes to, can I get the best world of both AI hardwares? So that's actually the PyTorch engineers and JAX engineers will really think about how can we make both models interchangeable. So we define we call it immediate representation. So we build PyTorch model after training, we can convert to JAX model, or vice versa. If we build JAX model, we can convert it into PyTorch model. So really I hope these two are, there's not a hope, it's reality. These two kind of frameworks, they complement each other so that we can both focus on research innovation and also to production performance and efficiency.
So it basically lays the ground to make and enable everything that's happening inside the models and in the application of the models.
Right.
Yeah.
And also and of course for both frameworks, we really want to open source. We want to really invite all the people in the industry join us and contribute and co-own this. Because if there's AI frameworks very too many, then everybody using different ones, then research ideas very hard to share. Right?
Okay, so maybe coming back a little bit to, I mean, we've talked about, how these models are being used. We have talked about a little bit what are the different layers, how are they kind of supporting each other, what do we need to consider for the different ecosystem players, but we haven't maybe talked so much about the contributors from the open source community overall without specific like affiliations. So how do you go about nurturing a healthy open source community, whether it's for frameworks or it's for the models it's themselves, and I would like to hear from all three of you, what are some of your key things that you think is key in order to nurture that healthy open source ecosystem?
Yeah.
So one of the things that happened with PyTorch is that at some point, this was entirely developed at Meta. This was, by the way, a descendant of a previous framework called Torch, which actually was developed partly in academia. It was developed by mostly three people, two people who were PhD students with me, and one person who was at the NEC research lab, Ronan Colobert, who is now at Apple. And then in my lab, there was Koray Kavicholou and Clément Farabet, who were both at DeepMind. Koray actually basically runs all the GenAI organization at DeepMind, and Clément who is here, I believe, is a VP in this organization. And they developed Torch and they were inspired by a previous system that Léon Boutou, Patrice Simard, and I developed when we were at Bell Labs, called Lush, which came from industry. So there's a long history of heritage and kind of descendants. But what happened at one point with PyTorch is that for the platform to be widely open without any kind of second thought, the ownership of PyTorch was transferred to Linux Foundation. So Meta does not own PyTorch anymore. It's still the main contributor to it, but it's not controlled and owned by Meta anymore. That's the best way to get a platform kind of widely accepted without people having second thought.
How have you seen that like changing, like that move? What did it result in? Did you see different contributors like racing in the
Yeah, I mean the result is now that if you look at typical R&D projects that people talk about, 70% of them are built on PyTorch. The exception being a bunch of people at Google and a few others who like JAX. I mean, JAX is a great thing. Too, and it's good that there are two different systems. I mean, there are more actually. There's other frameworks also, but they're not nearly as popular. So for foundation models, though, that's not entirely possible, and it's not possible for various reasons. So there are, I used to be, I'm still to some extent, an open source purist, in the sense that, when some company was claiming to open source something and it really wasn't an open source, license, I would be one of the people who say like, that's not really open source. And now it's true of Llama. The license that Llama is under is not technically completely open source because it comes with restrictions. And some of those restrictions are due to regulations. There are regulations in the world that say, have like cascading liability, for example, or there is, geopolitical question, and there is like, acceptable uses and not. There's all kinds of things, and so the license comes with restriction because of regulatory restrictions, essentially. And in my opinion, the biggest danger to a vibrant open source world in AI is regulation. So some of you may be aware of the fact that there was a law that was passed in California called SB 1047 that basically was written by people who believe AI is going to kill us all. Okay, and so they had provision in there so that if you were to develop a very powerful AI system, you had to basically get a license. And this would not just be restricted to California, it would apply to any company that has business in California, which means the entire world. And the entire industry, except for the tech company you don't like, were...
Which one don't I like?
Well, Anthropic and OpenAI were kind of in favor of it, more or less. Or at least they were not like squarely against it, because that provided regulatory capture for them.
It was a badly drafted piece of legislation that was rushed through, and it was vetoed, right?
So Meta was squarely against it. All the VC industry was against it. All of academia, with a few exceptions, Yoshua Benju and Jeff Hinton, were completely against it. And in the end, the governor, thankfully, vetoed it. But what it would have caused is cascading liability, so that if you are a company like Meta or Mistral or whatever, and you open source an engine, and someone somewhere in the world does something bad with it, you would be liable for the bad side effects. Now, that would have stopped and killed the entire AI ecosystem in one day. And because it would be too much of a risk for a company to just assume this. And when you think about it, it's completely ridiculous. Like if Linux runs the entire world, right? I mean, every computer within the noise, every computer in the world runs Linux, okay, except a few desktops and like a few iPhones, but like a minority. Like every other computer, which is a vast, enormous number, runs Linux. Your car has probably a bunch of computers that run Linux. Your cell phone, if you have Android, runs Linux, obviously. Your router runs Linux. The cell phone tower runs Linux or BSD, perhaps. But it's open source. It's even more
Is there prediction in there, Yann?
So the point I was going to make is that no one has ever sued Linus Torvald or the Linux Foundation for something bad that happened with your router just because it runs Linux, right? If you sue someone, you sue the manufacturer of the router. You don't sue the person providing the infrastructure software. So the idea somehow that you should have those cascading liability for AI because AI is special somehow is insane.
And is there prediction in there too? Like, is that what you think gonna happen also to the different players in the AI ecosystem? Is open source gonna prevail there similarly as it has done with Linux?
Well, I think ultimately because AI is going to become a common platform, it's going to have to be open source because everything that is a platform is open source, right? There is a drive from industry users, developers, etc., to use open platform because they are more flexible, customizable, portable, secure, everything, right? So because foundation models are expensive to build, they cannot be built by many people. In the end, they're going to have to be open source because they're going to constitute a unified platform, if you want.
I would use Wikipedia as an example.
Yeah.
So Wikipedia is entirely in the open, right? Then if you go to Wikipedia, the information is almost 100% accurate. If you are a vicious user, you go there and you change some information to like inaccurate, but 5 minutes later, somebody overwrite it, right? So same thing for the open source AI infrastructure software. Like PyTorch JAX, we put in the open, we invite the entire community to join and to look at it, to contribute. Then we have to believe the entire community has a lot of smart people. They're all very good people with good intention. When they contribute, they actually make the open source software really good. But one thing I do want to mention is if open source needs to have a governance plan. In other words, if everybody, hey, I own this open source repository, I can go there randomly change stuff, then it's very quickly get out of control. Right? Just like because if somebody, hey, let's renovate this, renovate this remote AI house. Everybody is architect. The AI house, the renovations be very horrible. Same thing for the open source community. It's yes, we need open source, we need contributors, but we need a very clear documented governance plan so people don't go crazy about it.
Do you see a gap there currently? Is there something that would be missing there that you wish for?
I do. So you mentioned that the PyTorch Go Linux Foundation. Linux Foundation is entirely open sourced. I think PyTorch has a very good maintenance the governance plan. Same for XLA, Google's XLA and JAX. We also have very clear documented governance plan. People go there, they contribute. We welcome contribution, but everybody contributes in a very organized manner.
So I guess you asked about open source communities, and there's been some nice examples, but every open source community, there's as many different ways of running an open source community as there are popular open source code bases. So the Linux kernel is managed in a very different way to Python, which is also open source, by the way. And one of the reasons is, and they're extremely robust, any social scientist, that's what they should be looking at. These are much more interesting models than companies have for deploying software. They're slower at first because they require much more discussion before a feature is agreed upon. But then the feature is likely to have been listened to by a larger range of people, which is why these softwares in the long term survive. I think the challenge we face within AI is that these communities were allowed to grow out of the bright light of the WEF. No one cared about the Linux kernel when Linus was initially working on it and even wrote an open source control system when the private closed source got closed down. No one cared about Wikipedia, or at least Jimmy Wales blocked the commercialization of Wikipedia. So we're mentioning these extraordinary models that it's questionable whether they can come into place now, because you're looking at something a bit more like, I think, the W3C, the World Wide Web Consortium, which also came about when the world was agreed what the vision of the web was. And actually, even today, I think it would be very hard to pull that together. And I think the real problem is the following. It goes back to what I think of as the problem of the scribes. So there's a really interesting question why writing was invented 3,500 BC, but it was only printing in 1500 AD, so 5,000 years later that you see the democratization of writing. And there's a lot of complexity to it, but one of the answers is no scribe was incentivized to democratize writing. So when you looked at how scribes operated, they kept the writing complicated. Is anyone here from Korea? I mean, it's amazing. Is it Hangul versus Mandarin script? Hangul's invented 1500, and it's a very simple script, but it's suppressed by the scribes. And the reason is because that's what keeps them in a job. Now, the remarkable thing about this over history is those scribes started out as people doing administration, but they became accountants, lawyers, the professions that we have today, the people that we rely on in our society to sort of administer things. They have responsibilities alongside power. Now, the problem is today, the written word is not how the world is operated. It's operated through digital systems, AI or not. And the people who are the modern scribes are the software engineers, and their guilds are big tech companies. So everything Yann and Bill have been talking about in terms of the development of these pipelines is catered towards what big tech needs. They're the ones that need fast inference. Like if you're, okay, everyone needs fast inference, as Yann was saying, but the priority for training versus inference is different in Facebook versus what it is in an academic lab, where I'm interested in getting the model together so that I can play with it. The inference cost is less important. And this is kind of the fundamental problem we face. This technology, there's no AGI. That's an absurd eugenic myth. But it is the most transformational technology that we have seen potentially for the last 600 years. And at the moment, it's not going to be deployed to the people who most need it, because we need those lawyers, those accountants, the nurses, the teachers, the doctors back in the game of administering our society. We cannot rely on whether it's big tech or whether it's Fujitsu with the Horizon problem in the UK or any other large-scale company that is isolated from its technical systems and doesn't support the people that we rely on in our society to deliver the solutions we need. Because while tech companies have gained the power, they haven't gained the responsibilities.
Thank you so much, Neil. I think that we are running out of time, but I think you made a very strong final point, and I think part of this democratization can also come from the open source community, or that's certainly the hope. And thanks so much for all three panelists for shedding a light on this, as you probably have grasped by now, quite complex set of concepts and layers that need to be considered in order to fully untap the potential of this technology. So a very warm thank you to all three panelists.
Thank you. Thank you.